All right, we're live.
All right. Hello, people of the world. Okay, so let's say who's who. We'll start.
Hi, my name's Ed Bear.
Oh, close the door.
Yeah.
And Ed is the current toolmaker in residence at Signal Culture.
Hi, I'm Luciano Rodriguez.
And Luciano is the current artist in residence.
Y'all know me, Jason, co-founder, and
Jason.
Phil, glitch art extraordinaire.
He's the art itself. Okay, so Jason Bernagozzi, Phil Stearns. I'm Debora Bernagozzi, co-founder and executive director of Signal Culture. And we're here in the Signal Culture Toolmaker studio, and Ed is going to show us what he's been working on for the past little over a week now.
So I'll just jump right in. For about the past 6 months, I have been experimenting and hacking on this PCB right here. I need to do due diligence and shout out the giants that I have, whose work I am leveraging. There's a bunch of work on mostly on GitHub, but a couple other people's blogs and stuff that have done a fairly comprehensive reverse engineering of this hardware. So there's like free Altium and KiCad projects that completely describe this on a schematic and PCB layout level. And they've the eBAS 4205 is available in the hundreds on AliExpress and Alibaba right now. So what is the eBAS 4205, you ask? It is a control card for a Bitcoin miner, meaning that this is a little computer that's made to hook up to a bunch of custom circuit boards with arrays, very large arrays, some 24 power 2 large, 16, 32, 64, 128 circuit boards of chips, SoCs specifically made to do the hashing for Bitcoin, right? So this is the brain that basically coordinates the hashing in a miner.
What I love though is you have nothing to do with Bitcoin mining.
It's true. Yeah. No, this is not an endorsement. This is simply a description of this particular piece of hardware and where it came from.
Yeah,
right.
So,
now, important to point out, this is now obsolete. Right. So the reason this hardware has come to me as someone that is obsessed and I think ethically obligated as a professional electrical engineer to deal with e-waste and deal with aftermarket and the toxic devices that have exited capitalism and become right. This is like $15 after shipping. Okay, so this circuit board here, right? Now there's a lot of circuit boards that are $15, but this circuit board has a chip on it, right? The little computer inside of it, if you know anything about embedded Linux, you might have heard about a Raspberry Pi or fancier, newer Arduinos or their ESP32. These are a lot of development boards or hobbyist boards that are little computers that you write programs for to do things. This is a similar embedded Linux machine, except for the chip on it is called Zinc 7010. Made by a company called Xilinx, which is actually owned by AMD now. I dare you to get online and try to buy one of those, right? It's about $100, okay? Just the processor, new. Or actually, honestly, like new and in quantities under 300-400, right? If you want to go and buy one of those chips, it's like $70, $80, $90, $100. And that's before it's soldered down to a hard drive, an Ethernet port, a power supply system, connectors, SD card, buttons, 256 megabytes of RAM. All of that's to say, right, the reason that this has attracted interest of other hackers and reverse engineers and hobbyists is because this is a really unique example, or a good opportunity if you're an expert to play around with some very expensive hardware on the cheap. The projects that have been before my residency here done with this are like there's a WRT meaning kind of like Wi-Fi / Ethernet router port for this. There's also what's called a software-defined radio receiver, an SDR project, which is probably the most sophisticated project that's publicly available, or at least that I'm aware of, for this board, that involves adding some extra circuitry and an antenna, and then providing a bunch, and then being able to visualize and tune and digitally analyze with your little computer things off the airwaves. What I'm here at Signal Culture doing, and what I've been most interested in, is taking this little hardworking miner and retiring it as an artist, right? We're going to take this circuit board out to the country and let it just paint for the rest of its life. Out of not one, not two, but I think it has not been done yet. I'm still at the 2 stage, 3 separate independent high definition, or at least 720p HDMI outputs. Also with custom video synthesis and processing gateware, right? So what's gateware? Gateware is a specific type of system design by digital logic design, which is different than software and different than firmware. If you which is what makes this little chip, the Zinc 7010, so expensive, right? It's got what's called an FPGA embedded inside of that little chip, next to a more traditional computer, a dual core ARM that runs Linux, right? What does that mean, right? I'm not, this is actually something that I'm still learning a lot about, so I'm not enough of an expert to explain it in like the most clear way, but the metaphor that I've got so far, right? If we imagine when we're making a computer chip or a circuit, right, that we're weaving a rug, okay? There's actually a lot of ways that metaphor goes very deep and is very technically accurate, okay? An FPGA, a field programmable gate array, is a rug that can change its design.
A magic carpet, if you will.
It is a magic carpet, right? Exactly. Yeah. You know, and that sounds complicated. That sounds like a complicated weaving project, and it is. It's a very complicated electrical design project, and these chips are often not seen in consumer grade devices. They're seen in specialty things like fintech, right? So there's a lot of like high speed trading is done by FPGA algorithms because money, right? People make things like Bitcoin miners out of FPGAs because money, and people make things like ultrasound machines, sonar machines, I guess it's kind of the same thing, radars, missile guidance systems, satellite communication systems out of FPGAs, ultimately because of money, but because you need something that complex to accomplish some of those complex technical tasks, like spinning 6 radar beams around in a circle 300 times a second, and then discerning how those fields bounce back, right? Okay. So that's a long-winded introduction to the eBAS 4205. And I encourage you to go check it out. And, don't buy one and throw it away because they're special. But if you look up this project and follow along on Signal Culture's work, you'll see what I am producing here. It's definitely a work in progress, and it's for everybody, not just me. Although it is a complicated, painful process to develop, compared to something like blinking an LED on an Arduino or a Raspberry Pi, right? So I guess I'll show you a little bit about the project that I've been working on that I've been calling Debazaros. You can see that there's one of the circuit boards that I was describing here with just a little adapter supply and some control and programming circuitry. The image you see on the screen is being rendered live out of a frame buffer from this device. It's this device right now through the gateware, meaning that the configuration of that digital logic has 2 HDMI ports. We're only looking at one right now. It's got several layers of different frame buffers. It's got a video oscillator that can be tuned in between 0.023 hertz, which is about one cycle, or no, 40 cycles every second. No, I did that wrong. 40 seconds a cycle, right? So a very slow motion up to 100 megahertz. That's also fed into a per pixel RGB matrix mixer with a couple other sources, and I'm testing and building that right now. So,
and what are you building it in?
So the gateware is built in a proprietary tool called Vivado. It is written in 2 different, you can't really see my screen, so we'll skip that, but it's written in 2 different text languages. One's called VHDL or VDHL. I think it's VDHL, and the other is called Verilog. There's also a graphical programming kind of block diagram flow tool built into the Vivado tool. There are basically no other options other than using that vendor supplied tool chain.
Okay.
For this particular custom chip.
Okay. And does that cost?
No, it is actually free.
Oh, that's great.
Yes.
Okay.
Yeah. And I should shout out that there is an ongoing and very challenging project to make fully open source tools for a lot of these FPGA chips. The current state of the art is a project. The umbrella project is generally called Open OSS, but it is most fully featured on a different set of chips made by a different company. So really, this is our only option here, is to install Vivado, which generates the gateware, the programmable digital logic. Vitis, which is a application development platform provided by Xilinx/AMD, which hooks up to Vivado. So if I design custom digital hardware, I forget which finger was which one, that custom digital hardware needs software which is unique to that digital hardware, right? So when you write a program for your MacBook or a Raspberry Pi or an Arduino or something like that, right? Every single Arduino can run that program, modulo chip architecture and stuff like that. But what we're doing is we're making a new chip architecture. So Vivado actually, in addition to exporting the gateware, exports a whole bunch of firmware library definitions, right? I say right, like you know, this is the simple stuff actually. So Vivado exports a hardware definition package which describes how to compile C code and C++ code, and it's got to be C or C++ because they demand it. Right, it's that's the only language that you can use other than assembly for these chips right now, and that's partially Linux's fault. But so once you've got that hardware definition export, you'll need the Vitus environment to be able to say write a program that does other things with the new hardware. And then the third piece, which kind of exists as like a third leg to the tent, is a set of tools called PETA Linux, PETA Linux, Pedal Linux, which builds a custom operating system, right? So just like to write the new application software for your custom digital circuit, you need to recompile and refigure the operating system for that custom circuit, so that, you know, maybe the best way to describe that is since this computer has 3 HDMI ports connected to it, the operating system would need to know that to use it, right? So all three of those things kind of work in tandem, and you're constantly testing with two and updating the third back and forth. And that's a lot of what I've been doing here at Signal Culture, is heads down in this room 10-12 hours a day till midnight,
or later
or later last night, yeah, waiting for the Linux kernel to compile for 15 minutes, waiting for the gateware to synthesize for 15 minutes, figuring out that something's broken or busted, and doing computer stuff and banging on things. And all of that said, what that means is that on a command line here, so I'm on this computer here, but I'm logged into this little computer over an Ethernet port, right? If I say write a magic number, which I defined in the gateware, to the, I hope this works, I didn't test this, right? To the digital oscillator on it, nothing happens until I fade up that signal in the pixel mixer, which probably, right? That's actually so I said there's multiple frame buffers. So I have like a couple layers of mixing of the frame buffer right now. So I actually wrote to the wrong register, but if I write to this one, we see a dynamic signal.
Yeah. Nice.
Okay. So from the computer's perspective, from a traditional video playback perspective, like I open a movie file on my computer, this is not a movie file. This is just an image, right? So I've opened a JPEG or a PNG and thrown that into the part of the computer which spits it out the HDMI player. But there is custom hardware here generating this pattern as we see it, right? If I had to break down specifically what I just did, it is the amount, the digital oscillator built in here is modulating the amount of 5, 6, 7 of green from the source, from one of the frame buffers into the red channel of the output. A lot of this stuff is going to be hard to describe with just gesticulation. You know, there's going to be a big documenting effort here, and that you know, like all good documentation, involves, along with the technicalities of the project. This is a cosine wave. At the same time, as the oscillator is also producing a half frequency ramp, which can also get mixed in like that. And I think it's honestly a little too fast right now. So if we go like,
You're getting great textures out of that.
yeah,
Oh,
Yeah, that's beautiful.
yeah, 1080p at 30 FPS is the maximum. Obviously, there's a bunch of different, tool software paths right now to go anywhere from 480. None of it's interlaced to go from 480 VGA, or I forget, is that SVGA? Anyway, whatever. Low standard def. All right, actually, let me do that real quick. I think I can. Are we still connected? Yes. So same exact data, just a much, much smaller slice of the frame buffer.
Oh.
Interesting. Okay.
Right?
Yeah.
And if we say write another test pattern to it,
Nice.
right? The frame buffer and the oscillator interact differently. The oscillator frequency didn't change or anything, but the what's the clearer way to say that, right? So we're looking at a much, much smaller slice of the frame buffer, but because the oscillator is affecting the pixel pipeline out of memory, right? The type and static and texture that we see is completely about the real frequency output of that wave into the gain, right? There's another number here where you can write like where it's like only a little bit of that frequency or a whole lot of that frequency to the point where it like clips and and distorts out and it, does bit flipping and a bunch of other nice digital kind of effects.
That's fascinating how it's clear and noisy at the same time
Well,
combined.
but also there are kind of areas where it didn't write, and then over time on the right hand side it slowly started to write in those areas, so probably through that frame buffer.
Exactly. Yeah, and that's something I'm really holding on to, and I'm like not fixing some of the.
It's very interesting.
Yeah. And there's it's like something I've been just playing around with today. I have the technology to do arbitrary frame writes into the frame buffer, but you can see exactly that effect that like if I clear, let's go to a different frame buffer and then we write the same pattern there, you can see it starts to fill in these weird ways and stuff like that. And some of that is things like processing speed and memory correction and access times and stuff like that, but some of it really is like versus clock and hardware access to that memory location out into the video system, right? Specifically, it's called DMA or direct memory access. And it's just like a little machine that doesn't take any CPU cycles, that when you configure it, it spits the frame buffer out, right?
Yeah.
So like we're seeing the kind of filling in as an interference between that frequency.
Yeah,
and
exactly.
the program
Yeah.
frequency.
Watch these go away.
Yeah.
It's so fascinating.
It looks good, right? It's fun, right?
Yeah.
And Dave Jones is on here and wants to know, is there any place to plug in control voltage?
Not yet. Yeah. So why don't I just let's go back to higher def, and all right, so you can see there's our 640 by 480 frame buffers like all in a row, right? And honestly, like if we wanted to rearrange how memory is used and stuff like that, so these things don't overlap, and there's a bunch of kind of ways we could make this cleaner or whatnot. But let me just throw some random. Oh, what was a good number? I didn't. Where's that? I rebooted the machine.
400.
What happened? Come on. Oh, wake up. I was freaking out. So a lot of this work is to just keep Linux stable, keep things on, keep memory access and stuff from going off the rails and triggering internal protections and stuff like that.
No panic.
Well, everyone in this room knows that the one time it's gonna act up is when you're showing it to people.
Not a lot is changing here. Why don't we? So talking about next steps, right? So I'm still building out and experimenting with how much video processing / some of these oscillators I can cram into the FPGA before I run out of space, right? There's on this chip, there's 28,000 gates. Dave knows what that means, which is a non-trivial amount, but it's not like one of the like 400,000 gates that you find in like a missile guidance system, which is a $3,000 FPGA chip. Once I have a sense about resource utilization and what's feasible and stuff, then I'll kind of solidify and do another pass cleaning up that software interface that you can see me and set. So instead of me having to type in 25 different 32-bit magic numbers that I've memorized over the last 3 days, you can do things like set oscillator frequency in code or from a Linux environment. I want to also make some hooks for OSC, right, or open sound control, so that anywhere over a Ethernet port or a UART port, you can send these things a message, right? At the other next important step that I want to test while I'm here, specifically because of Signal Culture's resources and expertise, is to see if I can shoehorn in, and this will be a real hack, because an NDI receiver, right? And so that's like a somewhat standardized, but unfortunately now closed source media server system that's just video over IP, right? But that means if I can get that working, that means that in addition to being able to play MP4s that are on the hard drive or on this SD card, you can then take 10 of them and hook these up to like Touch Designer or Jitter or any of the Signal Culture apps, or, you know, there's Siphon NDI converted anyway. Like it opens up a lot of possibilities in terms of sources for video. All of those things, in my mind, come before the CV input, because the CV input is kind of a trivial hardware issue, honestly. Like, I am not, just because I don't have the it blows up the scope of this project to do any sort of video CV input, video rate CV input, like first class. Like if we happen to have, like, you know, a megahertz of bandwidth on an analog input, right? Like that's great, and we can plug it in here. But I think for flexibility for right now, it's still going to run through that software stack I'm describing, right? Mm-hmm. So I would rather fill up the FPGA with trippy video stuff and then have a bunch of different inputs, if it's an analog input or a microphone or OSC, have those write to these registers through software, because it's fast enough. Like it really, like, you know, it can draw. It is struggling right now with completely unoptimized code to write 1080p frame buffers quick enough for video, but every free 720p 60 hertz, it can play movies back, right? And that means that short of any sort of very complicated analog modulation into the digital oscillator stuff, right? Like things that happen, right? will be fast enough to render.
Great.
You know, so that's a very technical way of describing it, and I'm kind of indulging the audience now, but like there are obviously limitations to that, right? It's you know, I had thought about turning one of the HDMI ports into a receive, right? That's still open. I've thought about SDI audio, right? There's actually a ton of SDI receive and transmit resources for FPGAs, but I mean that's not useful to anybody else. And honestly, I don't have a lot of SDI hardware anyway, so it's kind of like, and this is not going to be a broadcast environment or a lot, or you know.
Well, and fiber's the future anyways. I mean, SDI is phasing out in the next 5 years, so
Yeah, you know, and so I the thing I like about HDMI, secretly DVI, right, is that it's ubiquitous, right? This is about $15, plug it into your TV and your projector at home, stop playing video games and start tripping out, you know, and maybe write some C code, or maybe hook it up to your MIDI synth through Max, or maybe just, you know, an OSC stream out of Touch Designer, right? An OSC stream out of Touch Designer and an NDI stream out of either of those things. And then it's you're even if you be able to do all the same modulation per pixel color stuff in Python or open frameworks or et cetera, or processing, et cetera, et cetera, et cetera, what we've got in the loop is a piece of hardware that human beings designed, human beings made, and then human beings basically threw away.
Yeah.
So we're keeping it, for me, as an electrical engineer, working to keep this stuff out of the trash, to make a lot of noise and yell at people about how poisonous it is, and how much we've already poisoned people and places and things and ourselves, to even make it, right? There's a sunk cost. There's an embodied energy in this object that you know, that I get real philosophical and moony about. You know, which is an important part of this piece, and it as an object, right?
Yeah.
And I will also probably take like 5 of them and my 12 junk video projectors and just drown a couple galleries in stroboscopic color fields and stuff too.
Great.
But yeah.
So after your residency, where you said you're gonna produce documentation, and I guess I shouldn't ask you if you're planning to share that, but no. This is not something that I think, you know, let's just talk through the economics of it, right? So honestly, to build new copies of this hardware would probably be something in the order of $50 in like 1,000 units, right? And I'm saying that's like a professional opinion that like people pay me $150 an hour. I'm like a circuit lawyer, very much. I've done those numbers, right? Yeah. And so, you know, honestly, that's a pretty good price point for a product, right? Yeah. And we could turn that around. It's not my design. Someone might turn around and be like, hey, that's my design. All of that stuff aside, it's not as interesting to me of a process, right? To make new hardware based off this. It's a ton of work to sell products like that. This is a weirdo video synth. I'm not sure I could sell 1,000 of these in 5 years, right?
You know, and by then it's like people are gonna be like, "What's an HDMI port? Oh my god, it's got an Ethernet port on that. You can't plug anything into that." Anyway, so that said, there's this, you know, I like talking through the other options, right? Okay, so I could reach out to one of the warehousers, resellers on Alibaba or AliExpress, and I'd be like, "Okay, hey, why don't you sell me 100 for $10, right?" And then I could get on Instagram, and no shade to anybody that does stuff like this, and I could try to sell these for $500 or $1,000 once I kitted it out and put a bunch of knobs and the CV inputs and the Mazzaros Extreme version comes out and stuff like that. That would I'm not as interested in doing that economically. For someone to try, if I'm not really worried about someone else doing that either. If it strikes you, like if you want to start flipping these boards, I know people have tried already to build other small projects off of them and stuff like that for resale. They have also honestly been used for the last 5 years, and you can tell. They come back, the solder joints are oxidized. There's been the people reselling them are actually already refurbishing them, so you can tell they've been recleaned. They've been through a reflow process to encourage the high pin count chips, which is the processor itself, the memory, and then the flash hard drive, all have hundreds and hundreds of solder points on them. And so basically you take an old board like this that might not be working, and then you bake it for a little while, and then more of them work, a la Xboxes 10 years ago and stuff like that, right? But it's basically just kind of a melt the solder so that the cracks get filled in kind of thing, right? So the caps are going to die sooner than later, right? Because they've been in service for a while. Some of them are really dirty, honestly, when they come, then they haven't been cleaned. What you will see on Alibaba, which is of utility for people that want to play around with it too, and have been of great utility for me, are people have designed. Would you hand me those two little circuit boards right there? These are new designs. These are people to try to resell these have made little adapter kits and little breakout boards. No, wrong way. This way. Yeah. With an HDMI port, with a USB-C power, with a little 5 volt to 3 volt, little support circuitry. And these are sold for like, $20, $30 beside those by a lot of the same vendors as like, development kits, learning, and honestly, that's probably the right market for these. It's ostensibly what I'm doing here. Yeah, I don't know. I've probably over answered that question.
That's okay. So it's sort of, you're developing in some ways a sort of a conceptual art piece itself. And so the development and documentation is sort of part of that.
Yeah.
And then you can also use it in a gallery situation yourself. And if someone else wants to make one, they can.
Exactly. Yeah. And honestly, there's going to be, I think another thing that excites me about that, keeping it open, I've forked off someone else's GitHub. So why would I pretend like I have, could lock all that down? And like, yeah, I'm putting hours into it and such, but there's enough of a barrier to entry here, like, that it doesn't make sense to lock things up anymore.
It's not a ton of people who can do what you're doing.
Yeah, and I'd rather have someone contact me and be like, hey, could you help me do this, or leave one here and maybe mail you guys some SD cards when I do update some software or something.
Fun.
And just to see it get used at all.
Sure.
Even if it's like a lamp.
Yeah.
In someone's house.
Yeah.
Also, what I really was driving it to say is, this is just one thing I want to do with it. If to lock it down is to brand it as, Ed Bear's super fancy recycled video synthesizer. And it might be better as a lamp. There might be some really cool lamp things you can do. Like, I came to this whole world actually looking at surplus LED wall controllers, which are also a place to get pretty cheap FPGAs, like $100 chips for $30. on a circuit board. But there's nothing stopping this hardware from being a big LED wall controller,
Yeah.
or a 80 out audio interface,
Yeah.
or a 40 input and 40 output audio interface, or and so I think there's a lot of
Yeah. Dave Jones said he missed the beginning. Can you say the name of the board again?
Okay, EBAZ, EBAZ 4205. Check it out. There's hundreds of them online right now. Please don't buy all of them. I only have about 5 or 6.
And Eliza Miller is thanking you for sharing and saying it's so interesting to see what you're doing during your residency.
Thanks, Eliza. Yeah. But feel free to contact Signal Culture, and Signal Culture, feel free to pass on my contact information to anybody that does reach out.
Okay,
Yeah.
great.
Yeah.
All right. Any questions from the folks here?
Fantastic.
Amazing, yeah.
Yeah, thanks so
bravo.
much.
No, I really appreciate the opportunity to do this. It's been so much. It's really been so much work that, like, just kind of putting on my project management hat about it. Like, I wouldn't be where I am now with this project without this residency until at least next fall. Like, you guys have really kicked this project almost a full year into the future, and it's
Wow.
really awesome, and I really appreciate it.
And I think that's so interesting because people are like, oh, well, I'm an engineer. I have a studio at home. Why would I need to go to a residency? And it's just not working on your other projects,
Yeah.
and having people that are excited about what you're doing. And
Mhm.
yeah.
Yeah, and to see the studio that you guys have together, and just giving me lots of ideas, and also anti-ideas
Yeah.
about how to construct this, or what might be interesting, or what will look different, or what are some of the just different design ideas. The library here, honestly, just to go through,
Yeah.
digital videos not that new anymore. There's you have a great archive of what people have been doing since there was digital video,
Yeah.
and before, and
Analog video.
yeah, but specifically applied to this, it's
Yeah.
like it's been a really great environment and a good resource. Yeah. And just to have the time,
Yeah.
just to have the time uninterrupted, right? Even and I do carve out a day or two a week to work on this stuff, but not honestly, the tool chain, like the actual building, the hardware and software and stuff like that, it's so fragile because there's no competition, right? It's so vendor locked down that it doesn't even have to be good or functional. I spent all yesterday, literally 8 hours yesterday, just figuring out on forums and Reddit and Stack Exchange and how to save a project in a way that it will not be corrupted by bugs.
Oh.
And let me tell you, you have to export the project in this very specific way into a script that will completely regenerate the project whole cloth. You don't save it. You save instructions to make it that are verified and tested. So inevitably, when either of those Petalinux, Vivado, or Vitus crash and just trash some important, complicated magic numbers that you didn't even know existed, that it's been hiding in some cache somewhere,
Yeah.
and you can no longer open or compile or etc. your code, or you're just getting weird errors, you just tear everything down and then run this script to re-clone it, born anew. It's that bad. And so all of that's just, sorry, that was a digression. Pardon me, I'm traumatized. But that's the type of momentum that you need to get through some of these things.
Yeah.
Like if I was working 1 or 2 days a week, that's all I did that week on that one. And frankly, I'm going to come back next week and kind of have forgotten some of it, or be like, where was I? Or, oh, I forgot. I got to clean out those. I gotta anyway.
Yeah. Oh.
Yeah,
Well,
sorry.
thank you
Thank you.
for sharing, and thank you for being our very first live stream on Patreon. It's exciting, and yeah, looks beautiful. So we're excited to see more.
Thank you.
All right. Thank you, people who joined us and people who will watch later. Bye.